Hey guys, I'm back. So today I'm going to be explaining square roots and cube roots. I know this channel is usually dedicated to physics, but a large component of physics is mathematics, so I thought why not have a fun day and talk just about math. So if you guys are of the hating math type, learn to love math and watch this video. So, I'm talking about square roots and cube roots, okay? If you don't know what those are, you're probably not going to understand anything in the rest of this video. But feel free to stay anyways, because you will learn a lot. Okay, so if you don't know, a square root is simply what number times itself will equal a second number. So for instance, square root of 100 is what number times itself will equal 100. 10 times 10, right? A cube root is the same thing, but with cubes. So for instance, what's the cube root of 8? What number times itself 3 times is 8, 2 times 2, which is 4 times 2 is 8. Okay, so that way the cube root of 8 is 2. Okay? So I'm going to be explaining fundamentally interesting things about these cube and square roots function that you didn't know before, or maybe you did, I don't know. And I know that these questions, if you're being asked by scientists or stuff, you will impress them if you know the right answer. This is something that they usually require when they interview you or something like that. It's going to make you sound intelligent. So, here goes. So everybody knows that for a square root, there is two answers fundamentally. Okay, so for instance, what is the square root of 49? It's going to be 7 and negative 7. Because 7 times 7 is 49, and 7 times negative 7 is also 49, because the negatives will cancel out, because negative 1 times 1 is 1, right? Negative 7 times negative 7 is 49, okay? So you're thinking, wow, that's interesting. There's two answers. Are there two answers for every square root? The answer is yes, there are two answers for every single square root function. Okay, so then the cube root as well. You're thinking, wow, okay, cube root. What's the cube root of 8? It's 2. Are there three answers, just like there are for square roots? The answer is yes. For the nth root, there is n answers. So for the 27th root, there are 27 answers. Okay? It's that simple. Now, finding it is a little bit trickier. We have to use something called polar form. Okay? Now, what is polar form? Well, if you were to take a regular coordinate plane, just an xy coordinate plane, nothing special, okay? And you're to plot a point, let's say 0, 1. 0, 1, the 0 stands for where it is on the x, and 1 stands for where it is on the y. So 0 goes 0 in the x direction and go 1 up in the y direction. And that puts our point right here, right just stuck on the y-axis, at y equals 1, right? Now, polar form is a little bit different. Instead of listing x and y, it lists r and theta. Theta being just the generic variable for any angle, just like x is the generic variable for any number, right? So, and r is the radius. So this means how far do we go and in which direction we go, instead of how far do we go right and how far do we go up, okay? So, this will make a little sense once I explain it. But say you have the point 0, 1, right? How far do I go? We still go 1 unit in the direction, because you can see here that this unit up is still 1. Okay, so that's our radius. If you're to take it from the center, the radius is 1. What's the angle? It is 90 degrees, okay? Because if we take it from the x-axis, you have to go 90 degrees and then go up 1. That fundamentally is what polar form is, okay? So, now that you know what polar form is, we can begin to understand a basic question, okay? What is the square root of negative 1? Well, the square root of negative 1 is actually not possible. It's not a real number, okay? So what do I mean by that? You can try all you want to find two numbers that multiply to be negative 1, and you won't find them. They don't exist, because if you multiply negative 1 by itself, I mean two numbers that are the same number, obviously two different numbers, that's easy. But two numbers that are same number, negative 1 times itself is 1, and 1 times itself is 1. Those are the two most obvious answers, and neither of them come remotely close to being correct. Okay, so we've invented this number called I. I is the imaginary number, if you will, because this number is imaginary. It's not a real number, it doesn't exist. We have two different types of numbers in math. We have real numbers and imaginary numbers. And these are the largest categories of numbers. Any other numbers you've ever heard of fit into usually the real category, so irrational and rational. Those are both real numbers, an irrational number being pi and a rational number being 6, right? Both of those are real. So real and imaginary is the biggest category you can get into, really. I'm sure some mathematicians will think of something that I've missed here, but comment away, guys. So, there are two types of numbers, real and imaginary. And we denote imaginary numbers with an I. Okay? So I just stands for the square root of -1. Okay? So being that square root of -1 is not a real number, that's why we call it I. Okay? So this means we can express every number in a sort of complex format. The complex format being real plus imaginary. So, you know, it's usually a plus bi, a being the real part, and b being the coefficient of I, so 7 plus 43i, or whatever. Have it. Okay? And we can graph these numbers as well. We take our regular coordinate plane and substitute y for I, okay? This way we put the real numbers on the x-axis, okay? And we put the imaginary numbers on the y-axis, okay? So now we, instead of having the x and y, we have the real and imaginary. Same thing though, if I was going to plot 1 plus 1i, I would still put it here, just as I would plot 1 plus 1 on the xy graph. Nothing different, nothing's changed, it's still just as easy to graph them. And you're asking, can we do polars in this I format? And yes, we most certainly can, and this is where it starts to get interesting. To do polars in this format, we use something called cis format, okay? You'll have to understand something for this format. I'll explain it later. Let me just explain. Okay, so if I take our standard point, 0, 1, and we know this is 1, 90 degrees in polar form because we go 90 degrees around from the x-axis, and then we go 1 up, and that gives us 0, 1. Does it work for polar? Let's try it. 0 plus I, okay, or 0 plus 1i. Right? Well, okay, it's going to still be 1, 90, okay, because you're going to go 90 degrees and then 1 up, and that's still going to get you to the same point, okay? It's still going to get you to 0 plus I. But that's not what we call it in polar, okay? We don't call it 1, 90. Or I really like talking in radians, so 1, pi over 2. If you don't know what a radian is, I'm sure you can get videos, but just for this video, note that 90 is the same as pi over 2. 180 is the same thing as pi. 360 is 2 pi. Pi over 3 is 60 degrees, and pi over 6 is 30 degrees. Okay, everything else you can figure out from knowing those. Okay, I'm sure you can figure out the ratios by yourself. You seem intelligent enough to do that if you're watching this video. Now that we know it's 1, pi over 2 for the number 0 plus 1i, this is not the format we put it in, like I said. We put it in something called cis format, okay? So cis format is going to look like this. Say, I'm just making this up, 7 plus cis 37 degrees, or, you know, pi over 12 radians, or whatever, right? What does that mean? Well, it really means to do this. So you're taking the cosine, so the first number is your r, and the last number is your theta. That's the same as it always is, okay? But it's what's happening in between, the cis thing. What does it stand for? It stands for cosine I sine, okay? So what you're going to do is you're going to take the r, and then you're going to put the cosine of the angle. Okay, r cosine of theta plus r I sine of the theta, okay? So you sort of have to distribute it in there a bit. So r cosine of theta plus I r sine of theta, okay? And if you'll notice, well, that's the same as our normal xy, or in this case a plus bi format. And yes, because r cosine of theta is the same thing as x, or in this case the reals. And r sine of theta is the same thing as y. In this case, the imaginaries, okay? So that's what cis stands for, okay? And if you want to convert from cis back to a plus bi form, you simply just do the cosine of whatever angle, multiply it by the radius, plus the cosine of whatever angle, multiply it by the radius, multiply it by I, or sorry, the sine for the imaginary part and the cosine for the real part, and that's it. So that's really it. So that's polar form in imaginaries, okay? And now you know everything you need to know to figure out why square roots have 2 answers, cube roots have 3 answers, and to figure out those answers for yourself. Okay? So here I go at explaining this. Okay? So let's go, let's say, well actually first let me explain how do you put something into polar. Okay? So how do you find the radius? Okay, if we're going to take any angle, the angle in this case is irrelevant. I'll use a different, easier angle for the example, but we're going to take an angle, okay, and we're going to plot a point at that angle, okay? We can draw a triangle, and this is in the imaginary grid, by the way, so just to let you know, not that it really makes much of a difference, but just because. So we're going to take an angle, and we're going to plot a point at that angle, okay? And the radius is, if we draw a triangle, okay, so the reals and imaginaries, the radius happens to be the hypotenuse of the triangle. And you'll notice this is always true, okay? And then we're going to have the both legs of the triangle, okay? And to figure out the hypotenuse, if we know the famous theorem, a squared plus b squared equals c squared being the hypotenuse, a squared and b squared being the two legs, okay? You take, in the a plus bi form, you take a squared plus b squared, right, is going to be equal to c squared. To find c, you do the square root of a squared plus b squared, okay? It's that easy. So that's going to give you your radius, okay? Because in this case, c is equal to r, okay? Now, how do you find the angle? Well, that's a little bit tricky, okay? If we're going to take, if we're going to denote, say this one, this angle is going to be a little bit easier, okay? We'll say it's 45 degrees for now, or pi over 4 radians. Okay, and we draw this triangle here in the imaginary grid, right? We set the radius equal to 1, let's just say, to make it easy, okay? And we draw the theta symbol right here, okay, because this is the angle that we actually want to know. Okay, how do I figure this out? Well, seeing as we now know the legs, because this is a plus b, right? A plus bi, we can do the inverse tangent of b over a, okay? Because why? Tangent is opposite over adjacent, okay? So if we do the inverse of the tangent of the angle will give us our opposite over adjacent, and the inverse tangent of the opposite over adjacent will give us our angle, and that's what we want. In this case, the opposite is the I, and the adjacent is the real, okay? So the inverse tangent of b over a in our a plus bi form, okay? And that's going to give us our theta, okay? So let's move on to an example that all of us know now that we have all of the basic math down, right? Fun math, right? So let's go the square root of -1, okay? So let's figure it out, okay? What is the square root of -1? Well, first we have to write -1 in our complex complex form, right? Regular a plus bi form. So -1 plus 0i. That's easy because there's -1 real numbers and there's no imaginary numbers. So that's 0, okay? Now we want to find the square root of that, okay? Now, I don't know how to do that in a plus bi form, but I do know how to do it in cis format or polar format, okay? So I have to first find the r and the theta. Okay, so to find the r, we do the square root of -1 squared plus 0 squared, and we get it's 1, so we don't even have to write the 1, because that's implied, right? Now to do the tangent, okay? So we do the inverse tangent of the b, which is 0, over the a, which is -1, okay? And 0, we know 0 over anything is just 0. So we do the inverse tangent of 0. Okay, and that gives us really two possible options, okay? Where is tangent 0, okay? So we know tangent is 0 at 0 degrees and at 180 degrees. But we actually have to figure out which one is it, okay? So in this case, if we were to graph it, right, just -1 plus 0i on the complex plane, we're going to find out that, hey, look, that doesn't look like 0 degrees to me. That looks like 180. So we'll put pi, because pi radians is the same thing as 180 degrees, okay? So now we have the square root of 1 cis pi, or just cis pi, okay? So to find that, here's what we do, okay? So the square root is the same as raising it to the 1/2 exponent, okay? Square root and 1/2 exponent are the same exact thing. So what we're going to do is we're going to take our radius, and raise it to the 1/2 exponent. Square root of 1 is just still 1, so we can write, so we know there's going to be two answers, because 2 to the n, right, so z to the n will give us n answers, right? So in this case, n is 2, so we'll get 2 answers. So we'll write 2 of them, 2 1s, okay? This is going to symbolize r for both our answers, right? Then we're going to do cis for both of them. Now, what we're going to do is we're going to multiply this 1/2 by pi, okay? That's going to give us pi over 2, right? That's easy. So one of our answers is cis pi over 2, okay? And our other answer is, if we notice there's 2 answers, right? And to split up 2 pi radians, or 360 degrees twice, you split them up by pi radians, or 180 degrees, right? 2 answers are going to be spread evenly throughout this graph, right? That's always the case. To spread them evenly out throughout this graph, they must be spread apart by pi radians. So in this case, we're just going to add pi to the pi over 2, and we're going to get our second answer of 1 cis 3 pi over 2. It's really that simple, okay? Now, if we're going to, so now we know our answers, okay? Cis pi over 2 and cis 3 pi over 2. Okay, so figuring these answers out now, is really the easy part. All you do is split it up. So 1 cosine pi over 2 plus 1I sine of pi over 2, and 1 cosine of 3 pi over 2 plus 1I sine of 3 pi over 2. That's it. Then you're going to get your two answers. So you get 0 plus I and 0 minus I, because the cosine of pi over 2, that's 0. Cosine of 3 pi over 2, that's also 0. The sine of pi over 2 is 1, and the sine of 3 pi over 2 is negative 1. Okay? So you're going to get I and negative I, or 0 plus I and 0 minus I. Okay? And feel free to check my work. Plug it into your calculator. I times I is negative 1, and negative I times negative I is negative 1. Also, okay? See, look, there's two answers, and you thought only I was the answer. Okay? Now let me prove it to you. I is the same thing as square root of negative 1. Square root of negative 1 times the square root of negative 1. The square roots will cancel out. It'll give us negative 1. Okay? Right? It's that simple. Now, negative I times negative I. So now that we've proven that I times I is negative 1, right? Because I is fundamentally the square root of negative 1. So I squared is going to be negative 1. You know, the squared and the square root cancel out. So negative I times negative I. Well, negative I is simply negative 1 times I. So if we do negative 1 squared plus I squared, right? You see that? So negative 1 squared is 1, and I squared is negative 1. 1 times negative 1 is negative 1. Oh my gosh, it works. Wow, that's amazing. So now there's actually two answers that you know of for the square root of negative 1, and you know how to figure it out. Okay, let's move on to a slightly more interesting problem, the cube root of negative 1. So it's obvious to all of us that negative 1 is an answer, right? Because negative 1 times negative 1 is 1 times negative 1 is negative 1. Okay? But I bet you didn't know that there are actually two more answers before you watch this video. And how do you figure out these answers? Well, we're going to use the same process we took before. So we're going to put negative 1 on the complex plane. Same thing as before, negative 1 plus 0i. We're going to take the cube root of negative 1 plus 0i. Negative 1 plus 0i is the same thing in polar form that it was before. It still consists of pi, cosine I sine pi, right? And we're going to go through the same process. So we're going to take the radius and we're going to raise it to the 1/3 power, or cube root the radius. You know, however you prefer to think of it. The cube root of 1 is still 1, surprisingly, so we can write 1 3 times to symbolize all three of our answers. We can write cis 3 times, and now we have to figure out our angles. Okay, so we know the power we're putting this 2 is 1/3 power, because that's what the cube root is, right? So we'll multiply the angle by that power. Okay, so in this case, we're going to multiply pi by 1/3, and we're going to get pi over 3. So that's our first answer, 1 cosine I sine pi over 3. Okay, and just before, we know that all our answers are going to be equally spread out over this plane. Okay, and we have to divide this plane into 3 equal parts. Okay, so in this case, we know that this is 2 pi, right? Because that's 360 degrees. And so 2 pi over 3 is simply 2 pi over 3. 2 pi divided by 3, we can just leave that as 2 pi divided by 3 because that fraction doesn't simplify. Okay, and that's going to give us 3 equal parts because we know these 3 answers are going to be spread out equally. So now we can simply take our cosine I sine of pi over 3, add pi over 2, and we're going to get cosine I sine of pi and cosine I sine of 5 pi over 2. Or over 3, sorry. So our 3 answers are 1 cosine I sine pi over 3, 1 cis pi, and 1 cis 5 pi over 3. Okay, because we're adding 2 pi over 3 every time. Okay, so if we're going to now take these answers apart, so for our first answer, cosine I sine of pi over 3, we're going to get cosine of pi over 3 plus I sine of pi over 3. Cosine of pi over 3 is 1/2. Plus I sine pi over 3 is going to be I root 3 over 2, okay? Now our second answer is cosine I sine of pi, so the cosine of pi plus I sine of pi. Cosine of pi is negative 1. The sine of pi is 0 times I, so we're going to get negative 1 plus 0 times I, so simply negative 1. And our last answer, cosine of 5 pi over 3 plus I sine of 5 pi over 3. Cosine of 5 pi over 3 is 1/2, and the sine of 5 pi over 3 is negative root 3 over 2 times I. So our final answer for that one is 1/2 minus I root 3 over 2. And those are all our answers. And you can go multiply each of those out 3 times, put them in your calculator, whatever you like, and you're still going to get negative 1, okay? So I hope you enjoyed learning how to find cube roots, square roots. Using this idea, you can really find any root you want. You just multiply, you just raise the radius to the same power. Okay, so the 1/3 power, the 1/5 power, the 1/19th power, the 1/64th power, the 1/2 power, whatever you want. And then you take the angle and you multiply it by that power. So if you were trying to find the 27th root and all 27 answers for some reason, you would multiply the theta, or the angle, by 1/27. Okay? If you're going to do that, I feel sorry for you. That sucks. So, and that's really it. And then you just divide 2 pi, or 360, into 27 equal parts, because each answer is going to be spread out equally. And you just add that to the angle every time. And that's it. So, thanks for watching, and I hope you learned a little bit about math and imaginary numbers. If math isn't your cup of tea, you can feel free to say so, but it is a very important part of physics, and it's good to be well-rounded. And while this isn't entirely interesting in the operation of our universe, the way we perceive the universe is through the use of math, so it pays to have a basic understanding of mathematics. Because while this stuff won't help you to understand the universe in your everyday life, we express the universe through complex mathematics such as polars and cosine isine and imaginaries and all this funky stuff. So it really pays to understand how humans understand the universe, which is through this complex mathematics. So even if math isn't your cup of tea and you really like physics, that's great. I commend you for loving physics, but math is really how this stuff is fundamentally expressed. That's not how it has to be fundamentally expressed, but that's just how people have decided to do it. There could be aliens that are expressing physics through other forms. Math is just a human concept that we've put on physics to allow us to understand it. But in the meantime, until we discover something better, it's left to math. And frankly, I don't think anything will be better than math ever. So, thanks for watching, and I hope you enjoyed it.